Alright, let's do some subtraction of rational expressions. The only thing difference with subtraction is that negative has to be distributed to the binomial or polynomial, whatever that's behind it. So we still have to figure out what the LCD is. So factor the denominators, x plus 3, x minus 3, minus x plus 3. Numerator doesn't change here. I could factor out a 2, but if you look at it, it actually doesn't help us any, so I'm not going to do that. And here we have an LCD is x plus 3, x minus 3. So the second expression doesn't have an x minus 3, so I'm going to go ahead and multiply by x minus 3 over x minus 3. 2x squared minus 30 minus, I have to FOIL those two, the x plus 5 and the x minus 3, x squared minus 3x plus 5x minus 15, all over x plus 3, x minus 3. Okay, go ahead and collect like terms. 2x squared minus 30 minus x squared. And if I look here, I have a negative 3x and a positive 5x. That's a positive 2. That negative makes it a negative 2x. And then a plus 15. Okay, I need more space, so let me change pages and I'll move on. Okay, I was left with, I had in the last page 2x squared minus 30 minus x squared minus 2x plus 15 all over x minus 3, x plus 3. Alright, continue to collect a few like terms. X squared minus, scratch that, a minus 2x minus 15. I can actually factor that. I get x plus 3, x minus 5, and I can cancel those off. So my answer is actually x minus 5 over x minus 3, and I'm undefined at x can't equal 3 and negative 3. Okay, why don't you try one? Push pause and I'll work it out and we can check answers. Okay, this is where we are so far. I've run out of room, so I thought I'd let you look at it before I moved on to the next slide. I'm still collecting like terms, but if you look up here, my LCD is 2x plus 5, 5x minus 2, so I had to multiply the first expression by 5x minus 2 over 5x minus 2, and the second expression by 2x plus 5 over 2x plus 5. I had to FOIL here, and here I just distributed. So here we go. That's where we left off in the last slide. So push pause and finish the problem. There we go. I tried a, c, and b on the numerator, and I could not factor it. So we have our answer, and it is undefined at negative 5/2 and positive 2/5. Okay, go ahead and try another one. Push pause, please. This is as far as I've gone. I factored the denominators, got an LCD, so I needed to multiply the second expression by x minus 8 over x minus 8. I had to FOIL these, which is right here. It's all behind the subtraction sign. So I collected like terms and distributed the negative. Okay, I'm going to push pause and move on to the next page to finish. This is where I am from the last slide, so I'm going to collect like terms a little more and see if I can factor it and cancel anything out. There we go. Okay, push pause and go ahead and check it out. Alright, some rational expressions are complex fractions. A complex fraction contains one or more fractions in its numerator, its denominator, or both. So if you look at this first one, the denominator has a fraction. So the complex fraction has a fraction. Here, the numerator has an extra fraction. Here, you're like fraction over fraction. Recall that the bar in fraction represents division. Therefore, you can rewrite a complex fraction as a division problem, then simplify. You can also simplify fractions by using the LCD of the fractions in the numerator and denominator. and I'm going to do a few of each type. So I'm going to change it to division problems and try to do an LCD of both the numerator and the denominator to simplify it. Alright, I have two fractions being divided, so we're going to simplify. I'm going to rewrite it, x plus 2 over x minus 1, and make it multiplication of the reciprocal. X plus 5 now goes on top, and x minus 3 on the bottom. And then we just multiply across. X plus 5 over x minus 1, x minus 3. Assume that all expressions are defined, and you're done. Just circle it and move. Another one, simplify, assume that all expressions are defined. I have 3 over x plus x over 2 multiply x over x minus 1. Okay, these are getting more complicated because we have more things to do. It's like all that we've learned so far in this section. We sort of have to do it all. So on that first expression, we need an LCD. I have an x in the first fraction and a 2 in the second, so the LCD is 2x. So I do 3 over x times 2 over 2 plus x over 2 times x over x. We're still going to multiply that by x over x minus 1 at some point. Oops. That gives me 6 over 2x plus x squared over 2x. Hold on to this until the end again. Okay, I'm going to move this way a little bit. So I get 6 plus x squared over 2x times x over x minus 1. And here I can cancel this, and I'm left with, 6 plus x squared over 2 times x minus 1. I think I left another page here. Yes, so my answer is x squared plus 6 over 2 times x minus 1. Okay, try this one. Okay, this is a little bit simpler. You might have to factor, but try it. It worked out that our answer is pretty simple. I factored the denominator here and got x plus 1, x minus 1. So these two canceled out, and all you're left with is an x. So 1 over x. Don't forget you need a placeholder on the top. Try another one. Another one that worked out pretty well. All I'm left with is a 10. Everything canceled out. Alright, let's try this one. 1 over x plus 1 over 2x times x minus 2 over x plus 4. For this first expression, my LCD is 2x, so I need to multiply that first fraction by 2 over 2. Because I have an x, I just need the 2. So multiply across. 2 over 2x plus 1 over 2x equals 3 over 2x. Let's bring that 3 over 2x up here and work with it. X minus 2 over x plus 4. Multiply across. I have 3 times x minus 2 over 2x, x plus 4. You can distribute at this point if you want, or just circle it and call it a day. Alright, these word problems. After some practice, you'll get the hang of it, but I don't particularly like them either. Something I shouldn't tell my students, but being totally honest here, let's work through it. A hiker averages 1.4 miles per hour when walking downhill on a mountain trail and 0.8 miles per hour on the return trip. Let's talk about that. You're going downhill, pretty easy. Going uphill, sort of hard. So of course you're going faster on the downhill than you are on the uphill. What is the hiker's average speed for the entire trip? Round to the nearest tenth. At this point, you're going to want to just add them together and divide by 2, but that's not how it works. So let's talk about it. Okay, I've got a hill. When I'm going downhill, that's one distance. When I'm going uphill, that's twice the distance. So our total distance is 2d. So d is one way, 2d is both ways. Our total time. And all the problems work like this. You set this up and start talking about each piece. It's just how it works. So our total time is going to be distance divided by rate. Because if you take your units, say miles divide by miles per hour, you're left with hours. Okay, the miles cancel out and the hours are what you're left with. So total time is distance over rate plus distance over rate. Okay, now average speed. Is distance per time, right? So we have distance per time. This is what we're trying to solve for right here. Okay, this last equation. So I'm going to turn the page and write it again. Okay, here's the equation from the previous slide. I'm going to change my pen color for a second because I want to show you guys something. What you guys are going to want to do is 2d, change it to a multiplication, 1.4 over d plus 0.8 over d. Okay, you can't do that. I cannot do the reciprocal of an addition problem that was in the denominator. Okay, it's just not a move that you can make in algebra. So let's just deal with the denominator and see if I can make a least common denominator in the denominator, if that makes sense. So let's go ahead and rewrite 2d. And I have d over 1.4. I'm going to multiply that by 0.8 over 0.8 plus d over 0.8 multiplied by 1.4 over 1.4. That leaves me with 2d over 0.8d plus 1.4d. 0.8 plus 1.4, 2.2d over 1.4 times 0.8, 1.12. Now I can switch it from a division problem to a multiplication problem. 2d times 1.12 over 2.2d. Simplify if you'd like. I'm not going to simplify the numbers. I'm just going to multiply them across. 2 times 1.12 over 2.2 gives me approximately 1. The variables are gone, so that's our answer. So approximately 1 miles per hour. Okay? Now, let me switch to another color again. I want to explain something. The original speeds, remember, it was 1.4 miles per hour to go down the hill and 0.8 miles per hour to go up the hill. If I just want to do an average like this, I would get 2.2 over 1, which gives me 1.1. And honestly, I mean, it's close, but it's not the same as the actual answer we got, which is why we need to treat the problem with a little more care than just adding them together and dividing by 2. Okay, this is a you try, but I'm going to go ahead and work it out too. I'm just asking if you don't understand it to rewind it and try again, okay? These problems aren't easy, but I really want you to understand them. Justin's average speed on his way to school is 40 miles per hour, and his average speed on the way home is 45 miles per hour. What is Justin's average speed for the entire trip, round to the nearest tenth? I think it's funny that Justin took his time to get to school, but he was really in a hurry to get home. But whatever. First of all, same setup as the last problem. Okay, total distance. It was 1d to get there, 1d to get back, so the total distance is 2. Total time. Remember, Distance divided by rate is time. So we have distance over 40 plus distance over 45. And the average speed. It is distance over total distance over total time. And I need one more piece of paper to work the problem out. So I'm going to move the slide and work the problem out. So again, we have 2d over d over 40 plus d over 45. Okay, again, do not do the reciprocal of that addition problem in the bottom. I'm going to rewrite that. No, I won't. I'll actually write it out. I'm going to multiply the first expression by, we're just going to make it easy and do 45 over 45. And do 40 over 40 here. There might be a different least common denominator that's smaller, but we'll still get the same answer. So I have 45d plus 40d equals 85, hold on, 2d over. I have 85d over 40 times 45, 1800. Now I can do a multiplication problem. 2d times 1800 over 85d. The d's cancel out. 2 times 1800 divided by 85 gives me 42.35 miles per hour. That's it. I hope that makes sense. We'll work a few more in your homework. But these are all the word problems are this type, okay?